So I'm really excited to be here at SignalConf, and I'm really excited to be presenting this information with you folks today. Before we get started, I know everyone's in the middle row, but if for whatever reason you want to have a version of this presentation on your phone or on your laptop, you can access it by visiting j.mp/ssc-live. And you'll be able to follow along and just stare at your laptop during the whole talk. I did wear jeans and a dress and wear my hair down for this, so please do look up on stage on occasion because I tried really hard to look good. And with that, I want to start off by posing a question to everybody, which is, why is Twilio such a popular company? Why are so many people here at this conference? Why are so many businesses building products on top of Twilio? Is it because it's a great product? Is it because of their great developers? Is it because of the strong leadership the company has? Maybe, it very well might be those things, but I think the real reason that Twilio is such a popular company is much deeper. And it touches on to the core of our humanity. It reaches into our desire to communicate with other people, to hear their stories, to hear their voice, to read their words. We've all felt that anticipation when we get those 3 blinking dots on our iMessages. Someone's typing us a message, whether it's a friend or a loved one. And that visceral and primal satisfaction you feel when you get a notification from your text messaging app or email is real to you, or the satisfaction of hanging up after a great video chat with your mom. Those are all real feelings, and that's what makes Twilio popular. And the most satisfying form of communication in all of mankind is the narrative, the ability to share a story. Whether it's paintings on cave walls, whether it's a long, funny skit that you watch on YouTube, stories are fulfilling and delightful things to us as people. And there's one place where stories are most important, and that's in the research lab. In research laboratories, in industry, and universities, scientists are making important breakthroughs in how we understand ourselves, our society, our planet, our universe. And those discoveries affect all of us. But how are scientists sharing those insights? How are they sharing their stories and their process and their narrative? And how are we getting access to it as a general public that's affected by these? I care about this process a lot. I care a lot about how people share knowledge, because withholding knowledge is a form of oppression. And I get to see the power that knowledge has through the work I do at my company, DISVA. I work with small businesses and nonprofits to help them with their data science strategy and analytics. And I discover amazing things that knowledge can unlock for businesses and consumers all across the world. If you want to learn more about all the stuff I'm learning, you can check out my website, which is safia.rocks. .rocks is an actual top-level domain that you can buy and just kind of be very full of yourself. So safia.rocks is where you can find out all about me. But enough about that. I want to talk about black holes. Black holes are regions of space where the gravitational pull is so strong that nothing can escape. 1.3 billion, with a B, years ago, while the first plants were emerging here on planet Earth, far, far away, thankfully, 2 black holes collided into each other and formed one supermassive black hole. Now, on Monday, September 14th, 2015, at 2:51 a.m. Pacific time, the waves unleashed when those black holes collided into each other, those gravitational waves, were detected by the laser detection system set up by the Laser Interferometer Gravitational Observatory. These waves are minute disturbances in space and time. Thankfully, we have smart people working to detect things like this, and they found them, that specific date, and that specific time. Not only did they find them and did they produce a press release associated with discovery like most scientists do, and then it lands on BuzzFeed in a crazy listicle somehow, they did something really big. They released an interactive notebook that contained the data that they used and the signal processing code that they used to analyze the data. And this is an interactive notebook that anybody with a computer and a fair chunk of curiosity can explore, analyze, and run. We're going to do that just now because we're curious people, right? So I'm going to go ahead and pull the notebook produced by the wonderful folks at LIGO. If it'll... Sorry. Awkward technical difficulties. Awesome. So this is it. This is the notebook that LIGO shared with the world. It's an interactive document. It contains some information about where you can get the data they use to make the actual discovery. And it contains interactive code cells that you can run. In this particular case, we're running Python 2 code that they've used to read in data, to do some numerical analysis, and you can read about what that analysis is, to create plots. And this is really important because you as a citizen and you as a curious person have access to the same exact process that those scientists did. Now, if you're like me, you're probably wondering, what sound do two massive black holes colliding into each other at half the speed of light, releasing energy equivalent to the mass of 3 suns, make when they collide? To which I say, make sure you've got the volume turned up on your headphones because we're about to hear it right now. Is everyone ready?
Yeah.
Do you hear that? How about now? See, it's 1 second long. It sounds like a bloop. Okay, you heard it. Awesome, people heard it. No one watching the video stream heard it, but no worries. And that's it. And this is a document that you all have access to. And if you come to me after the talk, I'll show you how to get access to it and how to load it. Let's head back to our talk because that was much funner. So I want us to take a moment and appreciate the awesomeness that just happened, because we were just able to not only analyze the data that was used by actual scientists, play around with it if we so desired, and if we were really, really into it, we could actually validate what they did and make sure that they actually did detect gravitational waves from 2 colliding black holes. And that's a really big deal. That's changing the way people do science. It's no longer having to buy expensive journals. It's no longer having to be in an elite, stuffy coffee bar in 17th century England. It's right there on your computer, available to you. And what makes all of this possible? What gives you the ability to view an interactive document that has executable code, plots rendered inline, narrative text in it? And the answer is ZeroMQ. But before I talk about the technology and what ZeroMQ is, I want to talk about what it helps us accomplish. Specifically, I want to talk about the Jupyter Messaging Protocol. Jupyter is an open source project that works to develop interactive web applications for handling documents like the one I just showed you. So documents that contain executable code, documents that contain narrative text, markdown, lots of fun stuff. And the Jupyter Messaging Protocol essentially outlines how a front end or a client, like the one I just showed you, interacts with a backend kernel that's responsible for executing code and maintaining program state. Really quickly, we're just going to go through the workflow of what happens when you run a code cell. So we start off, and we've got an executable code cell on a front-facing client. In the particular application that I showed you in that Electron app, the code cell was a React component that encased the code mirror front-end tool. So you've got an executable code cell, just some fancy front end on the front. And that executable code cell has an event tied to it that sends a JSON payload over to a set of communication protocols that hand it over to a kernel, which is actually responsible for executing that code. Now you're probably wondering what the communication protocols are. And if you haven't picked up on my Star Trek obsession between the way Greg introduced me and some of the slides I have in my talk, you now know I'm obsessed with Star Trek. Voyager all the way, TNG sometimes. Original series, never really got into it. So let's dive deep into those communication protocols. How do they work? Well, we can really approach them in two ways, which is what do they do for the user on the front end and how are they implemented on the back end? So there's the front end and what communication socket do they go through? So as a user, I want to execute a piece of code. I have an execute request. I go ahead and send that execute request through a specific socket called the shell socket. The shell socket is responsible for reading my request, analyzing and making sure that it's the right request structured properly, and then passing it off for execution. Now let's say that that particular code that I want to execute renders a plot, like the plots that we saw in the interactive document that we were looking through. In that particular case, we have an I/O publication socket that's responsible for publishing that content to the front end. And these are important messages and useful things like plots. You need those in science, graphs and stuff. And let's say that that particular code that you're trying to execute is requesting some kind of input from the user. Maybe it's the raw input function in Python or read function or whatever fancy new programming language is hot nowadays. Well, it goes through the standard input socket, which, as you might suspect, is used to get input from the user, because that's important. Now, let's say that we have a user and they've written tons of like fancy code in their single code cell. Let's say it's training a Bayesian classification model, and let's say half of it's taking a really long time to run, and halfway through they realize, oh, there's a typo in one of my parameters, or there's something wrong with this code cell, and I want to stop executing it. I want to halt everything. Well, for super important messages like that, you have the control. Oh my goodness. Oh my good. Oh. Everything, that was disastrous. I just ruined the movie for you guys, I'm sorry. For critical messages like that, you have the control socket. And you can think of the control socket as the muscle in the family. It trumps precedence over all the other sockets. So you can say, control socket, I need you to kill the kernel right now. And it'll do it, regardless of what the shell socket's working on, or what any of the other sockets are doing. And then to tie all of these up, you want to make sure that your system is alive and well, right? Because that's important. You have the heartbeat socket. And the heartbeat socket is really simple. It sends a single byte string message to your front end telling it that everything's okay, we're good to go, Captain. The Borg are not coming to attack us anytime soon. Hopefully not for a while. So I want to zone in on those arrows that were used to connect the front end to the communication socket. What kind of data is actually being transported when I click play on a cell or when I press Control Enter to run it? And then magically there's output. Well, it's a JSON payload, our favorite type of sun next to bison. Well, okay, that was an awful joke. I don't expect you to laugh. And the JSON payload is really an easy way for us to track when a certain message was requested, who requested it, and what session it was running in, what kind of messages it is, a way for us to track metadata about the message. And that's all that's transported through these sockets, is JSON messages back and forth. Very simple, robust system. And the actual sockets are implemented as ZeroMQ, using ZeroMQ sockets. I pulled this right out of the Jupyter code base. If you're interested in checking that out, it's all open source and on GitHub. And what you essentially do is create an application that reads in messages through a socket, parses them, channels them to the appropriate relays, runs them if necessary, returns output to the user, all based on ZeroMQ. And I sort of lied in my talk title and in my talk description and like at the beginning of my talk, and I've just been lying to you consistently this whole time, so I apologize. We're actually not going to talk a lot about ZeroMQ because I'm running out of time and because I want to focus on what you can do with this communication protocol, because that's all it really is. It's a way to talk between a front end and a client to exchange executable code. So how can you make use of this communication protocol in your applications? What cool things can you build with this? And I want to talk about some awesome stuff that the open source organization Interact, without the I, because it's all about we, is doing. You can find them on GitHub as Interact without the I. And they've been doing some really great work to make it easier to engage with this Jupyter Messaging Protocol. And I want to showcase 2 of the tools that they've open sourced that you can use in all your applications if you're so inspired to really supercharge them with interactivity. The first is a simple NPM package that allows you to use this communication protocol that I just outlined, this exchange of JSON payloads with specific specifications through different sockets via a ZeroMQ backend in the very traditional sense, the same way that the original Jupyter engineers implemented it. But here's the thing, that protocol that I just described is just a way of communicating data. It's an agreement of how things are represented and what to do when you get data of a certain representation. And so you could communicate it over a protocol like ZeroMQ, but you could also do it over a protocol like Socket.io if you are so inclined, and you can use both of those things. And these are all open source packages, just an npm install away. You can have it in your application, you can start using it, the documentation's super clear and concise. If you want to learn more about them, you can come talk to me afterwards and I can talk your ear off, but you probably just want to grab a beer after this since it's the last talk of the day. And then you have the data that you exchange in order to execute code and to send information from a kernel to a client. How do you actually represent that interactive notebook document, those cells that are code cells or markdown cells? Well, for that, you have another awesome package that's also open source under the Interact organization called Commutable, which allows you to interact through JavaScript with that data representation of that notebook. So those code cells, those markdown cells, being able to move them, being able to interact with their outputs, being able to edit their source. Super awesome, fun stuff. And you can build awesome things with this. And it's 6 p.m., so you're probably not feeling super creative and you want to be inspired. So what kind of awesome things can you build? Well, the cool thing about this is that you can have one backend, so one kernel running, and you can have it connected to multiple clients. You can have one kernel running on a high-performance machine somewhere, and you can have a REPL connected to it from a terminal. You can have a text editor connected to it. You can have an interactive document editor like the Interact notebook I just showed you connected to it. They can all be connected to that same kernel running on the high-performance compute. You can run awesome code. And you can run code in a context. Because here's the thing. We no longer just develop APIs or develop software in a singular sense. We interact with lots of different APIs at the same time. And the context that you use your applications in is varied. And you want to be able to build code that is embedded in the documentation or embedded in its use case. And with an interactive document format like the one I just showed you, you have the ability to tailor different dashboards, tailor different documentation suites to the platforms and the code that you're writing at your company. If you want to get more inspired about that, come talk to me afterwards. I hope I'm keeping you on the edge of your seats. Good. And lastly, you have the ability to build computing-driven narratives. When everyone in the world has a laptop on their lap, you have the ability to unlock amazing things with code. And indeed, the world is quickly moving that way. We see a lot of things like data journalism. We see a lot of citizen science. We see a lot of people running machine learning algorithms on their laptops to solve challenges for money, for prestige. That's really changing the way that people share their stories. Everything's compute-driven now. And when you tell these stories, you really need to have a way for people to not only share that narrative, that markdown cell, you need to have an ability for them to share that code cell. And what's the big deal with all of this ability to execute code interactively on a front end separate from the back end that's running on? Well, you get to liberate the front end. Why do we have to write code in a plain old text editor? Why do we have to interact with code in a REPL? Why can't we build our own dynamic ways of interacting with our software and with sharing our software with others? And you get to free the narrative. Why should a narrative be constrained to a static research paper in a journal that no one's ever going to read, when it can be fed to people's laptops and desktops in an interactive format in an engaging way? And finally, you can open the code. I'm really excited about open source software. If my talk loaded with open source tools and all that fun stuff hasn't proven it. Open source is really important because it gives you the opportunity to share your creativity with the world and to inspire other developers to be just as creative and even more creative than you. So when you open source your code, you're not just open sourcing your idea, you're open sourcing the potential of millions of others' ideas. So that's really important. The major keys from this talk, because I'm heavily inspired by DJ Khaled as well. Narratives are important, stories are important. They're as important to us now as they were when we were painting pictures of donkeys and placing our hands on cave walls. You need to liberate the context your program runs in from the actual program execution. You need to be sure to share and develop in the open and make sure that your one idea inspires millions of others. And most importantly, with all of the things I just showed you, with the tools that I just showed you are available, I want you to go forth and help people share their story. I have 3 minutes left, which is awesome because I just gave you 3 minutes extra to grab a beer or to talk to me, hopefully. Thanks for coming to my talk. I hope it was everything Greg promised it would be. I think he overhyped it. I'm Captain Safia everywhere on the internet, so if you want to find me on GitHub or Twitter or Friendster or Napster or any outdated technology, I am Captain Safia on it. Email me your feedback, safia@safia.rocks. I want to make this talk better for potential future presentations. If you have a good joke that I missed telling, please do so. Come up to the front if you want to see the entire Lego notebook and if you want to hear black holes colliding one more time. Go get beer.